Let us now consider a situation where we have a voltage-controlled voltage source. Say we want to determine the node voltages at nodes A and B, given we have a VCCS that has an output of 4Vx, where Vx exists across our 4 ohm resistor. Step 1 is to assign our nodes, which were given as A, B, and C, where C is designated as ground, and leg currents. I1 runs through a 4 ohm resistor between nodes C and A, and I2 runs through a 10 ohm resistor between nodes C and B. Step 2 is to assign our voltage potentials consistent with our passive sign convention. We prescribed I1 based upon Vx, which was already given, and V2 now corresponds to our 10 ohm resistor, where its polarity is based upon the directionality of I2. We put a dashed box around our VCCS such that we recognize that VA and VB are going to be described by the output of 4Vx. Step 3 is to determine the proper number of KCL equations and apply them at our non-zero and non-specified nodes. We see that we have 3 nodes and 1 voltage source, thus we need 1 KCL equation, and we will prescribe this KCL equation at our supernode. Applying our KCL equation at our supernode, we have 3 amps entering from our independent current source. We have I1 entering as well as I2. Thus 3 amps plus I1 plus I2 is equal to 0. Step 4 is to apply Ohm's law in terms of our node voltages. Thus our KCL equation becomes the following: 3 amps plus I1, which can be expressed as Vc minus Va per 4 ohms, plus I2, which can be expressed as Vc minus Vb per 10 ohms, is equal to 0. We have 1 voltage source. Thus we need to construct a constitutive equation. That is, 4Vx is equal to Va minus Vb. Now, Vx is expressed in terms of the voltage drop across our 4 ohm resistor. That is, we can say Vx is equal to Vc less Va, where Vc is our ground, which has a value of 0 volts. Thus, Vx is equal to minus Va. If we substitute in our known value for Vx into our voltage source equation, we have 4Vx, which is equal to minus 4Va, which is also equal to Va minus Vb. Thus, we can say Vb is equal to 5Va. Substituting our knowns back into our KCL equation, we have the following: 3 amps plus I1, which was Vc minus Va per 4 ohms, where Vc is equal to 0, plus I2, which was expressed as Vc minus Vb per 10 ohms, where Vc is equal to 0, implies Va per 4 ohms plus Vb per 10 ohms is equal to 3 amps. Now we have 2 equations and 2 unknowns. Thus we can construct our system of equations in matrix form. Starting with our voltage source, we have 5Va minus Vb is equal to 0. And from our KCL equation, we have 1/4 Va plus 1/10 Vb is equal to 3. Thus, solving for Va and Vb, we see our voltage at node A is equal to 4 volts, and our voltage at node B is equal to 20 volts.